and welcome to my introductory video about CAD and specifically Autodesk Inventor Professional, which is my personally preferred CAD package because it's really user-friendly and it just works great. So Autodesk Inventor is free for educational purposes and it's reasonably affordable if you need the full commercial license. And all these details, of course, you can find on autodesk.com. So Autodesk Inventor is what I used to design the kilojoule, which you see here. It's being disassembled right now because we are building the green envy, which you can see here on the screen. And it is, of course, also designed in Autodesk Inventor. So I use this Autodesk Inventor to build racing motorcycles. I also teach CAD as my day job, but I love CAD so much that I use it for even more than my day job and my cool hobby. I use it for daily things that I need or like. So I like handbags. Well, can I say? It's just a thing. But I was so disappointed with the handbags that were available in the stores, so I decided I'm going to make my own. So what did I do? Of course, I designed it in Autodesk Inventor and 3D printed it. So you can use CAD for pretty much everything, from racing motorcycles to handbags, and of course every single product there is in the world. So this is my introductory video. I hope you will enjoy it. It is meant for people that have very little CAD experience before, or has very little experience with Autodesk Inventor. So I hope you will enjoy it. Make sure to follow along in the hands-on exercises, because hands-on is how you learn CAD. And if you have access to a 3D printer, you can also 3D print the little object that we're going to make. If you don't have it, don't worry, it's not required at all. So let's get started with CAD. Autodesk Inventor is a solid modeling design software, or as we call it in daily speaking, CAD, computer-aided design. And it's used to design, to visualize and simulate products before you actually manufacture them. There are three main file types in Inventor. There are parts file with a file ending IPT. There are assembly files with a file ending IAM, and drawing files, which come in two versions, IDW and DWG. And then there is a fourth version of files, which is presentation files. We won't cover that much in this course. In addition to this, there are also a project file, .ipj, that will be important when you start working with assemblies. So let's take a look and see what these different file types actually means when you're working with Inventor. So we have the part files, the .ipt, which is an individual part such as this wheel cover here for my racing motorcycle. So that one is created as an individual part. Then I take these parts and you put them together in an assembly. So here's an assembly of my whole next motorcycle, the Green Envy. And you can see this is the wheel pant you just saw, the wheel cover that you just saw in the part file, and this is an .iem file, which is an assembly. But this is not just a pretty picture that's suitable for putting in information material or online. This one, under this bodywork you see here, is actually the entire design. And this is, where I have made the bodywork transparent, and you can see everything that's inside. So you can see the frame, the powertrain, you can even see a version of me inside. Maybe not totally realistic, but good enough to see what the seating position would look like. And from these parts files and assembly files, you can actually create drawings to have things manufactured. So that's one of the things I do. So the steel frame you see inside here is laser cut and welded together. So I took this file and generated a drawing, and these are the big tubes that need to be laser cut. So I sent this off together with the Inventor files to the company that does the laser cutting. So all this design work was done in Inventor and then sent off, and it will become reality. So this is one way you use Inventor. You design your whole thing, and then you can look at it, you can visualize it, simulate it, test it, and so on before you actually manufacturing it. And the manufacturing is also associated with these files, so you use these files for the actual manufacturing. So when you put a part or any kind of file into another file, you actually reference it. So the part here in the assembly, they are just referenced in this assembly file. So all the parts still exist as their individual files. And if I change something in one file, it updates in all the other files where it's referenced. And just to give a simple example, this is a beginning of a phone stand that you will make later on in this tutorial. So I made this phone stand, and then I made a drawing of it. So you can see this is the drawing that shows some of the dimensions for this phone stand. But say I don't like these sharp corners, I want to change that to rounded corners. So I round the corners like this. There we go, nice rounded corners. And if I go back to my drawing, you can see it now has updated. So all the files are referenced to each other. So you make an update in one file, it will be reflected in all other files where that file is being used. So that makes CAD incredibly powerful as a design tool, and makes it really easy to make edits wherever you want to make edits. Let's also take a quick look at see what we have in the user environment here with Inventor. We will get back to this later, but just at first glance you can see you have two major parts of the user interface. You have what we call up here what we call the ribbon. That's where the majority of all your commands are. And if you want to know what something means, I'm quite sure all of this looks quite confusing right now, but it will be quite clear very quickly for you. If you hover over one of these buttons, a picture shows up and it shows you what this command does. So it's a little bit of an explanation to what these do. And another big part of your, important part of your user interface is this part here, typically referred to as the model tree, and that shows the history of this part. So what we we added these rounded corners by using the fillet tools, and we can see that that fillet happening, the fillet event is here in the model tree. And if we want to change that, we do that here. So we can right click on this, edit this feature, and maybe we decide we want the corners to be rounded much more than what we did. So we just edit that, and now it has bigger rounds on the corners. And if we go back to the drawing, we can see it has been updated here as well. So I think you will find this very easy to work with. Of all the CAD packages on the market, Inventor is one of the most user-friendly. So I think you will enjoy it, and I think you will quickly get up to speed and understand what the functions do. And hopefully you find it very enjoyable to design your own things. The best way of learning any CAD package, including Autodesk Inventor, is to actually make an item. So in this course, we will make this little phone stand. So this is a stand that is designed to be 3D printed, although we will not 3D print it in this course, but you could do it your own, on your own if you want to. You put your phone in it and you can comfortably watch all those CAD videos on YouTube. And I added the I love CAD text because I truly love CAD, and I'm hoping when we're done with this course that you will love CAD as much as I do. So CAD is an incredibly powerful tool for any engineer, regardless of discipline, and it's the design space where we take the ideas in our heads and we materialize it and make it come to life. So I will guide you through step by step how to make this phone stand. I will also give you all kinds of tips and tricks that will make CAD easier for you and that will be very useful both in this course and in future courses. So let's get started making this thing. So the very first thing you have to do is to create a new file. And to do so, let's go to File, let's click on that, and then say New, click on that. And then we have several options. And because we are in New Zealand, we want to get a metric file. So make sure you choose metric, and then let's choose standard millimeter IPT. And you can see we also have choices of assemblies, drawings, and presentations, and we will use some of these later. But for now, let's just do a part file, so a standard millimeter IPT. Click Create. There we go, we have a new file open, and the first thing you should do every time you start a new file is to save it. So let's go to File and Save. And now you need to give your file a logical name. So it is technically possible to change a file name after you have created a file, but you shouldn't do that because later on we will use these part files in what we call assemblies, where we put several parts together. If you do that and then afterwards change the file name, things will go really bad and your assembly will fall apart. So make a habit of never changing your Inventor file name after you have created the file. So choose wisely. So I'm going to call my file phone stand because that is exactly what we're going to make today. And then just click Save. Every Inventor part will contain at least one sketch. A sketch is a 2D drawing or 2D sketch that we use to create the 3D bodies that make up the solid model part. But before we start a sketch, let's just take a quick look at the environment we have here in Inventor. So up here, this is called the ribbon. It has lots of commands. Most of these probably look very confusing right now, but at the end of the course, most of these will be very clear to you. We have multiple tabs. We will mostly just use the 3D model and sketch tab, and then we will use to annotate a little bit in the drawing environment, but not here for parts. To the left we have what's called the model tree, and that shows everything we have done, which is pretty much nothing so far. So to start a sketch, let's click this Start 2D Sketch button. And for any of these buttons, if you hover over them just for a few seconds, there will be a help dialog box showing up that tells you what this do. So if you're not sure what the button does, just hover over it and this little dialog box will tell you how it works. So let's get started by clicking the Start 2D Sketch. So what shows up here now are the origin planes. So these are the planes we can choose from to sketch on. We have the XY plane, YZ plane, and the XZ plane. You can also see these planes if you expand the origin folder in the model tree. You can also see the same planes. It doesn't really matter which plane you start sketching on, but my favorite is the XY plane. So if I don't have a reason to do anything else, I recommend always start your sketch on the XY plane. So let's just click it to start the sketch. So now we have started a sketch. You can see the sketch tab here is highlighted. We also have a big green tick mark. It says finish sketch. That indicates that we are in a sketch environment and we have an open sketch. We can also see that sketch number 1 has showed up in our model tree. But before we start sketching, we have to decide what we're going to sketch. So let's take a look at the drawing of this phone stand. So there are many ways of creating a part in CAD, and there's nothing really right or wrong. It's a personal preference. I like to pick a way that is quick and easy, because I always want to save time and effort if I can. So the way I will make this phone stand is that I will start by sketching this cross section. So it's kind of a rectangular box with a rounded end. So let's ignore this cutout for now. Let's ignore the I love CAD text. Let's just look at the cross section. So that will be a rectangular box with a rounded end and a hole through it. So that's where I'm gonna like to start sketching this, and then we will extrude. We will make this a solid body in this direction. So we need to say what dimensions we need. So it's 65 millimeters from here to here, and it's 10 millimeters from there to there, which means the whole thing is 75 millimeters long, and then it's 15 millimeters tall. The exact dimensions for the hole, we will get those later. But I will start to make a box with a rounded end. So the way sketching works in Inventor, the way you really should work the sketches, is that you first rough sketch approximately the shape you want, but you don't worry too much about the exact dimensions in the very first step. So let's just sketch it for approximately the shape we want. So to make this cross section that's a box with a rounded end, I'm going to pick a line tool, and then I want to start in the origin. When you hover over the origin, it will light up. Always try to connect your sketch to the origin if you can, at least your very first sketch, because that will make a rigid, good, rugged sketch. So let's click on the origin and then just draw out the line. Actually, we can go to the left. And then don't worry about the exact dimension. Just left click on your mouse. That's when the mouse marker turns green on your screen. That means that I'm left clicking. And then we can see the line command continues. So we're now creating another line. We want to go straight down. It shows 90 degrees. So we don't want to be off like that. We want to be straight down. And then click again. And then we will go out to the right. And click again. And now we don't want any more lines. And you can see the line tool is kind of still hanging onto our mouse marker. We will press escape key on your keyboard. Escape is used a lot in Inventor, and that's how you cancel any command you click or press escape on your keyboard. So we have now the most of the rectangular shape, and then we want this rounded edge. And to do that, we will use the arc tool. So click on the arc tool, and then we're going to click on the end of this line, which also happened to be origin. We will click on the other end, and then we will draw out an arc. And don't worry too much about it right now. Just put it anywhere. I want you to notice that we get two symbols here at this exact size. Let's avoid that for now. Just make it a little bit smaller or a little bit bigger. So just click there. So now now we have our rough shape. If you can't keep up, then just pause the video or go back if you needed to. Make sure you follow along and do this, because it's the only way to learn is to really do hands-on work. So make sure that you have come to this step so you can keep up with the instructions. So the first dimension I want to add is this 15 millimeter height. So just quick look at the drawing. We want to add this 15 millimeter height. So that will be the dimension from this line to this line. So I can click on that line, and pull it out a little bit, click again, left click,
and then I will type in the dimension 15, and then I can either click this green tick mark or I can just press enter. Now you can see the whole shape grew, and to get back you can either scroll the middle mouse wheel, or you can click here and say zoom all, and that will fit everything you have done in the window. You saw I moved the sketch sideways. It's called pan, and you could do that either by holding down the center mouse wheel, or you can use the command here by clicking the hand, and that will also make you pan. I like the center mouse wheel. It's the easiest way to pan. So the next thing we want to do is to set the exact dimension of this arc. If we look at the drawing, you can see the radius is 7.5 millimeters. If the radius is 7.5, that means the diameter is 15. That happens to be the same dimension as this height. And if you think back and remember geometry, this actually means that this circle is tangent to the upper plane. So we can go two ways. We could add a dimension. We're still in the dimensioning tool, by the way. And we could just say that we want this to be 7.5 millimeters in radius. But that is not quite as clever. There's a more clever way. So I just undid this. And I will actually, to delete the dimension, you click on it. First you press escape to get out of the dimensioning tool. So if the dimensioning tool is activated, you click escape to get out of it. And then you click on the dimension and you press delete on your keyboard. Alternatively, you can right click on it and say delete. So we will do a different way of dimensioning this. So you know you can do the dimension. Try that. Pause the video if you need to. And then delete that dimension again. And we will try another thing. We will use a constraint. So dimensions and constraint together is what sets the shape and size of a sketch. And if you hover over this, it tells you about the tangent constraint. So let's just click this tangent constraint, and then let's click on the arc and click on the upper line. Now this symbol comes here, becomes visible, and it shows that the arc and the line is tangent. And then click on the arc again and click on the lower line, and now it's tangent there as well. So why do you want to do this, you may ask? Why can't we just put in 7.5 millimeters? That seems much easier. Well, there is some really clever things with CAD, and that is that it is parametric. That means that you can have parameters where you change one dimension and other dimensions change with it. So let's try one thing. This is a little bit of a sidetrack, but I think you will enjoy it. So let's press escape to get out of this constraint. Then let's go to your 15 millimeter dimension, double click on it and change it to 20. And now you can see the arc over here grew with this dimension because we didn't give it an exact dimension. We actually told it to always be tangent. If we had set the dimension to 7.5 millimeter radius, this wouldn't have worked. So let's go back, change this dimension back to 15. So we're missing one dimension, and that is the total length of this thing. And if you look down in the bottom right hand corner, you can see one dimension needed to fully define and constrain this sketch. So we know this whole thing is going to be 75 millimeters long. So if we take the dimensioning tool, we click on this line, we click on this arc, we will discover a problem. Because you can't easily dimension to an arc kind of end. Instead, it will dimension to the center of the arc. So we could, of course, calculate. We know it's 75 millimeters from here to here. It's 7.5 millimeters from here to here. And we could do that math and we could put it into the box. But we can have Inventor do the math for us. So type in 75 millimeters, which is the total length we want, minus 7.5 millimeters for this section here. And then press enter or click the tick mark. And now, how do we know that this one is actually 75 millimeters long? Well, we can do geometry and math and we can conclude it, but I will show you a little bit of tips and tricks. And that is if you go to inspect. So stay in sketch, click on the inspect tab. This is a very useful thing to know. You will have a lot of use for this tool later on. And there's a measurement tool. So click on that, click on this line, and if you hover over the end of the arc here, you will have a little green dot showing up. Click on that one, and now it shows you that this dimension is indeed 75 millimeters. And just press escape to get out of the measurement tool again. Click on the sketch tab to get back to the sketch environment. And now if you take a look down in the right hand corner, it says that the sketch is fully constrained and all the lines have turned blue. That means that every dimension is defined, and that's a good thing. So if you change, this is in the default color setting for Inventor. There are ways of changing the colors on your screen, and then the lines will maybe turn a different color than blue, but don't worry about that. In the default setting in Inventor, when all lines are blue, that means that the sketch is fully constrained. But we're missing one thing. We need that hole. So let's make that hole by drawing a circle. So draw a circle somewhere inside. Don't line it up with the center point, because the hole is not going to be exactly concentric with this arc. So let's draw it like here. And you can see now you get this little horizontal dotted line. That means the center of this circle will be at the same level as the center of the arc, and that's a good thing. So you just draw it. And then let's dimension it. And we're looking at drawing. It's 6 millimeters in diameter. So let's give it 6. Press enter. So we want this circle to be horizontally aligned with the center of this arc. And there are some clever constraints for doing that. We could go in and just dimension it 7.5 millimeter from here to here. That would be easy. Would be the quick click and then 7.5 millimeters. But I will show you a different tool. So if you added that dimension, let's undo and remove it. Instead, we will use a constraint, and this is called a horizontal constraint. So click on that. Then click on the center of your circle. You see this dotted line shows up. And then click on the center of the arc, or the green dot that's the center of the arc over here. Now these two are constrained, and if you press escape, grab the center of the circle, you'll notice you can't move it up and down, but you can move it sideways. There is one dimension needed, as you can see here, and that is that we haven't constrained where this hole is. So if you look at the drawing, it is placed 5 millimeters from the edge here. But we know it's difficult to dimension from an edge of this rounded edge. We will dimension from the other end. So from this end to the center of the hole. Holes are always dimensioned to their center, by the way. It will be 75 minus 5 millimeters, so 70 millimeters. So go ahead, click the dimension tool, and this time we will click the corner just for fun. You can click on the line, you can click on that corner, or you can click on that corner. That all will result in the same thing this time. To the center of the circle, pull up and type in the dimension. And there it is. Now it's fully constrained, and you have finished your first sketch. Good job. So let's just finish the sketch and then we will continue to the next video. The previous video was quite long. This one will be significantly shorter. So you've finished your first sketch. So let's get it into the center so we can see what we have actually done. And this is also a very good place to save your file. An important thing to know is that Inventor does not auto-save your work. You have to manually save it, or if you have some kind of computer crash, power blackout or so, you will lose your work. So be sure to regularly save your work. So if you haven't saved, click save now. So we have our first sketch, but this is a 2D sketch. You can actually, if you use the free orbit command, you can look at it and see it. It's just a 2D wireframe in space, and that is no fun. So let's make this a 3D part. What we will do is that we will use the extrude command, and extrude command is found here in the 3D model tab. So click on extrude, and what we want to extrude is this shape. So now we will go from this cross section to this, there we go, to this 3D part. So we have this cross section and we will extrude it, and we will extrude it for 30 millimeters. So you can see the profile button is highlighted already automatically. So when you press extrude, this dialog box comes up. So if we hover over this cross section, you can see it suggests we extrude the area, not including the hole, which is exactly what we want. So let's click on that. And now you can see it creates a solid body. On default, extrude is always 10 millimeters, but we want it to be 30, so we will type in 30. Another way you can set this is by pulling this arrow. And you can extrude this way, you can extrude that way. And while you're pulling this arrow, you can see the dimension here change. But we want to do 30. You can also choose which direction you want to extrude it. Direction 1, direction 2, or in both directions, and both directions sounds great to me. So let's do that. There's a fourth option where you can extrude in different distances in different directions, but we don't want to do that today. We want to do 2 directions, and note that 30 is the total distance from here to here, so it will extrude 15 millimeters in each directions. We want the output to be a solid. And there's also different options here, but we will look at those later. For now, we call it distance, 30 millimeters, and we will extrude in both directions. And then just click OK. And here is your very first solid part. Let's make sure to save it, and then let's continue to the next video. The first sketch you created was on an origin plane, so we can start a new sketch again on the origin plane if we wanted to. We have all the origin planes available here in the model tree. But you can actually start a sketch on any flat face on a solid model, which sometimes is very handy. So let's start a sketch on a face. So let's click the Start 2D Sketch button again, and then we will select this face here. And you can see these faces light up when you hover over them. But you notice you cannot start on this rounded face. You have to choose a flat face to start a sketch. So we will click on this face, and now we are back in the sketch environment. As you can see, Sketch tab is highlighted. We have the green tick mark here, and Sketch 2 has appeared in our model tree. So what we want to do now is, let's bring in the drawing. We want to make this cut here. So we will sketch this section, and then we will cut it with using the extrude tool, but instead of adding material, we will remove material. So we need 2 lines, or actually 3 lines, or plus the top, 4 lines all together, and they need to be at a specific angle and some specific dimensions. But let's worry about the dimensions in a little bit. Let's start again by making a rough sketch. So let's use the line tool. And we can see if we hover over the top here, it actually snaps onto it, and we can see a little yellow dot. So let's just kind of eye up where we think this cut should start. It's, I think there. Let's click. Draw down a line. We don't want it to be 90 degrees this time. We want it to be 60 degrees. But you should, again, eye it up a little bit. I think that's pretty good. Left click. Line tool continues. We just go a little bit of a distance. Now we want to be perfectly horizontal. Click again, and then go up towards this upper line. And if you notice here, right here, to the left, there are 2 parallel lines showing. You can see here is a little constraint tool and a constraint symbol. And if I set it right here, you can see that to the left. That means that the 2 angled lines, kind of hard to show it to you here, because if I move the mouse marker, the constraint symbol would disappear. So if I'm out here, there is no constraint showing that these 2 lines are parallel. And here they are parallel, there they're not parallel. I'm going to set them so they're not parallel, just to show you how to use the parallel constraint tool. So I'm just going to click so I snap onto the upper edge. So just click there. And then I would want to do one more line from here to here. You may have noticed that the line tool stopped working. That's because I connected to something else. I had to click again and click over here to get a line. If you didn't follow, I think you will be right. Be all right. So now we have drawn our 4 lines. I will press escape to get out of the line tool. So I hope you can see this well. It's not super easy to see these green lines on the gray background, but I hope you will do all right. So this is what we have done now. We have sketched this, a rough outline of this cut we want to do. And if we want to look directly on this face again, you can use this little cube up here, and it's the front, is what we sketched on. So I will click there, and it will get us back into this view. So what we want, so we look at the drawing, we want these 2 lines to be parallel. So let's just start by setting them parallel. We could have opted to make them parallel when we sketched them. Inventor suggested that, but I chose not to. So let's go to the constraint menu. Click on this parallel constraint, and then click on this line and that line, and now the 2 are parallel. That will come in very handy, and I will show you right now why that is. So they're now parallel, but we want this angle here to be 60 degrees. So let's do the dimension tool, and let's dimension from this line to the top edge. Click once and then type in 60 for 60 degrees. And you notice now, because these 2 lines are parallel, when I change this angle, that angle changes as well. So we don't have to dimension this angle, it's automatically dimensioned by this angle. I hope you followed in that. So let's take a look at what other dimensions we need. So we can start with the length of this bottom piece. So because these 2 lines are parallel, the distance from here to here will be the same as from here to here. And if we read the drawing, that is 12 millimeters. So that means the length of this line will be 12 millimeters. So just click on it, type in 12, and press enter. And again, if you get behind, just pause the video, go back if you need to, and make sure you keep up and do all these steps. Another dimension we want is the dimension from this edge to this edge, which is 15. And I'm quite sure you know exactly how to do this now. So we do the dimension tool. And here you will notice, if you try to dimension this line, that won't work well. That's the wrong dimension. So press escape. Instead, you will have to dimension from this corner here. We can zoom in a little bit to show it better. From this corner here to that corner there. And now you can add 15 as a dimension and zoom out a little bit. We can see that the lines are starting to turn blue, which means they are getting more and more constrained. And we're missing one dimension, and that is the distance from the bottom of this cut to the bottom edge. So that is 5 millimeters. So let's add that. It's 5 millimeters from this line to the bottom edge. Pull it out, type in 5, press enter. And now it is fully constrained. And I will show you a little bit of a trick, but it comes with a bit of a warning. Don't overuse this function if you don't have to. So say you're sketching something like this, you're making whatever design you're working on, and no matter how hard you work, down here it may say that there is still not fully constrained, and you can't figure out what dimension is missing. The reason you want to fully constrain a sketch is that it makes it very rugged and robust. So while you can extrude and work on sketches that are not fully constrained, it's not recommended that you do it. But sometimes you just can't figure out which dimension is missing. And I will show you how I call it the magic button. It isn't called that, but that's my name. I will delete this dimension to show you how this works. So up here is a button that's called Automatic Dimensions and Constraints. So right now we have one dimension missing. If I click this button, it says it needs one dimension. I say apply. It will suggest, or not really suggest, it will add in the dimensions missing to fully constrain the sketch. And now it is fully constrained. But what happens is that it just locks the sketch into place exactly what it looks like. So you want to make sure to add all the dimensions you want before you use this button. But this is a magic button to use if you cannot figure out what that last dimension is that's missing. You will find it useful later on. For now, we will know all the dimensions we need. But when you get to your design project, that is good to keep in mind, that button will add your last constraints and lock down your sketch and make it really robust. So enough about that right now. So your sketch is done. And let's make that cut. So you can actually extrude while you're still in the sketch environment. So you don't have to finish your sketch to extrude. So let's just go to the 3D Model tab and then press the Extrude button. And now Inventor is automatically selecting this new area we sketched. It's assuming that that's what we want to cut out, and that is completely correct. But we don't want to add material. This time we want to remove material. So we have some options here. Join is what we used last time, but this time we will use cut. So we will remove material instead of adding material. And we could use this distance and type in the 30 because we know it's 30 wide, but there are better ways of doing this. We want it to cut through all. So why don't we want to use 30 and distance? Well, if we type in 30 and we cut through distance, it will work fine for now. But say we later go in and say we want to make this 40 wide, not 30, and you open up the first sketch you made, the first extrusion you made, and change that to 40, then suddenly your hole will only be 30 deep and it won't go all the way through. So if you say through all, it will always go through all the material, no matter if you change other features. So if you want it to go all the way through, use all. So we have selected the profile, we have selected cut, the extents are all, and just click OK. And there it is. Your cut is done. And I find it a lot of fun just to kind of rotate, orbit, and look at my design. I find that very enjoyable. It's almost like you made it in real life, but it's only in a digital space. So this is starting to look like the phone stand. So let's take this opportunity to save your part, and then let's continue to the next video. The next feature we want to create are these cutouts here. So if you compare the sketch, so compare the drawing to your part, you can see that you need to cut out 2 sections here in order to make this shape. And this will be very similar to how we made this cut. So this will be a breeze for you. So let's just start a 2D sketch again. Let's pick this upper face and we will start the sketch here. So we want these 2 rectangular cutouts. So let's choose the rectangle tool. And we can see here, if we hover over the corner, it will automatically snap to the corner, which is very convenient. So click once, left click, and then drag out a rectangle of, it doesn't really matter exactly what size it is for now. We will dimension it in just a moment. And then just do another one as well. And you can see here, at that point, the 2 rectangles actually line up with each other. And that's what we want, so let's choose that. Let's add some dimension. So we go to the dimension tool, quick look at the drawing. We want it to be 10 millimeters by 10 millimeters, both of these rectangles. You can see that here. So the cutout from the edge here to the edge here is 10 millimeters. And the dimension from the corner here to that edge is 10 millimeters. So that means this cutout section will be 10 millimeters. Don't worry about these rounded corners. We will do that last. Okay, so for now, we will just cut out these 2 squares, 10 by 10 millimeters. So dimension tool, click on that, and then click on this side, pull it down, and then add 10 millimeters. And now you see both of these change size because they are connected with an automatic constraint. We want this side to be 10 millimeters as well, and there are different ways we can do this. We can click on the line. We can click on this line and this line, or we could click on the 2 corners and pull out the dimension. And it already happens to be exactly 10 millimeters, so let's just accept it. We also have to do this one to make that exactly 10. So now it seems like we've added all dimensions, but there's still 2 dimensions needed. And we see that lines are green. So let's see what happens if we click the automatic dimensions and constraints button. Apply. I don't quite like that, how it adds a 0 dimension and a 20 millimeter dimension here. So I'm going to say remove and done. And then I will do this myself. So let's see if I try to move this, what is happening? You can see that this square here can move that way, and this square can move this way. So that means that this line is not constrained with that line, or this corner is not constrained with that corner. So let's do this. I like to use this constraint. It's called a coincident constraint. And I want this corner here on our box we just drew to align with the corner of our part. So I will click there. And now you can see there's only 1 dimension needed. So let's do the same thing with this box. Click on the corner, click on that corner, and now the sketch is fully constrained, just like we want it. And I just like to orbit to see exactly what we have done. So you can see here is an interesting thing. I told you can't start a sketch on a round surface. So we started a sketch on this flat surface, a flat face, but the sketch can extend outside this face. There's no limit for how big a sketch can be. The face just defines a plane where the sketch is located. So now we have made 2 sketches that extend over this rounded surface so we can cut through. So cutting is exactly what we're going to do next. So go to the 3D model tab. We can still stay in the sketch environment and click extrude. So we have several areas that are closed sections, and Inventor isn't really sure what we want to do, so we have to select them ourselves. So these are the two areas we want to extrude, but we don't want to add material, we want to cut. So let's click the cut button. And I will show you something else. So last time we used all. That would be great, that will cut right through the part, just like we want. But I want you to be aware of another command as well, and that is to. So that will cut a certain distance to another feature, and you choose that feature. So we could choose, because we wanted to cut all the way through, we turn this over, so I free orbit, I hold down my shift key on the keyboard and the center mouse button, and then I free orbit and turn it over. And then I click on the bottom. Now the cut goes all the way through to the bottom. Well, what's the difference with all, you might say? This is just this very same thing. Well, in this particular case it is. But let's say if you wanted this cut to be the same distance, same depth as this cut. So I'm going to choose 2 again, and then I'm going to click at this bottom. And now you can see this cut is the same depth as that cut. And we couldn't do this with a cut all command. But this is not what we want. I just want to show you how you can use these different commands. So say 2 and the bottom, and that cuts all the way through. And then just click OK. And now it's starting to look like our phone stand that we are planning to make. So let's save it and let's continue to the next video. The next thing we want to add is the I love CAD text on top of our phone stand. So if we just take a quick look at the drawing, we can see the letters are 3.5 millimeters tall in this direction, and then they are embossed, so they're sticking out 1 millimeters. There actually are no dimensions showing exactly where this text is located, but it's pretty much centered on the face. So if we center it on the face, we will be just fine for this exercise. So let's see how we can add text. So the way we add text is that we add it in a sketch. So let's just start a 2D sketch again, and then click on this top face where we want the text. If we look in the create box here up in the ribbon, we can see there is a text tool. So let's just click on that. And if we hover over it again, you get a dialog box that tells you, or a box that tells you what this does. So we want text, and we want the text to be centered approximately, well, center start approximately there. When we click text, this dialog box pops up, and I will enter my text here. So I love CAD exclamation mark. So on default, the text is 3.05 millimeter tall, but I want it to be 3.5. If I just go in here and change, you can see that the text size actually hasn't changed. So in order to change the text height, you have to highlight the text and then change the text size. I also want a bit of a bolder font, so I will make it bold, and perhaps choose something else than Tahoma. This will be completely your choice. You can click and choose any text type you want, and if you want a different message, feel free to do so as well. I think I want an Arial black. It's a pretty fat text, and text height is set, and I will just say OK, and there is my text. But if you were to orbit this, you will see it isn't embossed yet. So this is just a sketch including text. It is not embossed, so extruded text. So if you aren't happy with the location of your text, First you need to press escape to get out of the text command. So press escape on your keyboard and you can see that text box is not highlighted anymore. And then you can move your text to any place you want. You can also use the rotate command if you want to rotate it to a different angle. And if your text would happen to be on, oh, come on 2 lines like that, that means that your box where your text is too small, and you will have to grab the side, make it bigger so it fits on 1 line like that. It is a bit complicated to try to dimension and constrain text, so we will not try to do that in this exercise. Just center it approximately in the center of this face, like that, and then just finish the sketch. So now the text is just a sketch and not extruded. So let's extrude it. Just like we extrude any sketch, we can extrude text. So click the extrude button, and then we will choose the text. So you can see if you hover over it, it will be highlighted, and then it will extrude very far if you just do the default setting. The default setting, if you're already done an extrude, it just remembers your last extrusion distance, which was 30. In our case, we want it to be 1 to make the text nice and low like that. If you were to want your text to be engraved, you will just choose cut instead, and you will go inwards and your text would be engraved. But in our case, we want it to be embossed, so we're going join and we're going outwards. Make sure your arrow is pointing outwards or it won't work. We all set distance 1 millimeter outwards and click OK, and there is your text. And if you want to do your name instead, feel free to do that. Play around with whatever you want. The way to learn CAD is to try different things, so feel free to try whatever you want while you're doing these parts. So let's just save it, and then let's continue to the next video. So you're getting close to finishing your phone stand, but there's one distinct feature that's still missing, and that is these rounded corners. So we can you can do rounded corners in several ways. When we did this first round, we made it as part of the sketch because it was just easy to do it that way. But when you want to do rounded corners like these, it's easier to just add them on at the end, and we are making these corners by using what's called the fillet tool. So a fillet is actually an inside round. So if you were to round it in here, that would be called a fillet. But when you do it on the outside, it's called a rounds. But the tool is called fillet. So let's call it a fillet tool. On default, the radius would be 2 millimeters of the fillet or round. But if you look at our drawing, we actually want the rounds to be 3 millimeters. So let's start by changing this dimension to 3. So you just click on it and type in 3 instead. Then this is quite simple. So we just choose the edges we want to have rounded. People may also call this filleted. Maybe not technically correct, but that's all right. It's the fillet tool. So let's round these edges. And there we go. If you accidentally click an edge, just, oh, I didn't mean to round that edge. What you do is you hold down the shift button, hold down the shift key on your keyboard, and you click on that line again, and you will unselect it. So we have selected the 4 corners we want to have rounded. And we can either click apply or OK. I like to do apply, then I can see what has been done. And then I will just click cancel to get out of the command. So this is how you add fillets and rounds. So play around a little bit if you like to. Let's make sure to save your part first while you're here. But you can try other things. You can try to do fillets here. You can see what happens if you do it on the inside. You can do a fillet here. You have to do fillets here. play around a little bit and get a feel for how this tool works. And if you do something you didn't like, well, if you're in this mode right here, you can just do cancel, or you can do the undo button here, or you can press Ctrl Z on your keyboard to undo. There's also a similar tool that's called chamfer. Difference between a chamfer and a fillet is that the chamfer is sharp. It cuts the edge off like this. On default it's 45 degrees, but there are other options as well. So try that tool as well, and if you want a different distance, you just change that here. Oops, 4 millimeters is too big, it can't be done. Well, 1 millimeters will work. And you can, if you type in a number that is too big, so Inventor can actually not make a chamfer that big, then the chamfer will disappear in the preview. You can see 3 millimeters will work. And again, if you select an edge you didn't want to select, just hold down Shift on your keyboard, click it again, and you unselect it. So try these and then undo it. And let's continue to the next video. And if you do things, and there is a limit to how much you can undo. If you find yourself that you can't undo something, well, you can just close your part without saving it and open it again, because you saved it before we started playing around with the chamfer and filleting tools. So have a go for it, have fun, and see you in the next video. If you take a look up in the upper edge of the window here, you can see it says generic. Generic means that there is no material assigned to this part yet. So if you click on the little chevron here, and you get a list of default materials that you can assign to your part. So a common material for little plastic toys and little gadgets is ABS plastics, which is a very strong and cheap plastics. So I will choose that for the phone stand. So now we have assigned a material, and you can see that also over here it changed from default to smooth white. So this is the default color for ABS, is white. And each material has its own default color. So if we were to make this out of steel, it will become, that's a strange color. Let's try stainless steel instead. That is gray. And so on. You can play around and take a look. And if we make it of glass, it actually is transparent. So each material has a default color setting with it, or appearance, as it's called in Inventor. So I will go back and choose ABS plastics again, but feel free to play around and try out the different materials and see what they look like. But you don't have to stick to the default setting for a material. So I don't want my phone stand to be white. I want it to be a different color. So I want it to be, I think I want it to be magenta. So I will choose magenta. So the material is still ABS plastic, but the appearance is now this bright purple pinkish magenta color, which I like. So, assigning material, it's not just about appearance. The material will also assign physical properties to our part. So go ahead first, just set the material to ABS plastic and then choose a color of your choice and save the part. So let's go ahead and do that. If you need to pause the video, do so. So I assume you have done this and then you have saved the part. So I will show you, with the material comes physical properties, and the way to find your part's physical properties is to go to the model tree with the part name, and then you right click it and you choose I properties. So right click and choose I properties. And here you can, there are all kinds of information about your part. We will go to the last tab, which is physical properties. And right now it says NA. So let's click update. And now it will populate all these boxes. So we can foresee we have ABS plastics is our material. The density, which is built-in value into Inventor, is 1.06 grams per cubic centimeters. And based on this density and all the dimensions we added, we can tell that our part weighs 28 grams. So you can tell how much it weighs. You can also tell its area and its volume, and then you have inertial properties. You may or may not have covered this yet, so don't worry about that. But here's a great way of knowing what your part weighs, and that's important in many applications. It could be simply for cost. You want to know how much material it would take to make this part. But certain applications such as aerospace, mass is super important, and you want to make something as light as possible, and this is where you see how much your part weighs, or the mass of your part. The material properties will also be used in case you do stress analysis or strength analysis of your part. We will not do that in this course, future courses, and you use these material properties for that as well. But that's outside the scope of this course. So have fun, go ahead, change colors, change material, see what it looks like, play with the text, play with fillets, chamfers, and whatever you feel like, and make sure to explore functions on your own, because that is how you learn CAD. Good job, and have fun trying out features in CAD. One of the very popular things to do with designs made in CAD is to 3D print them. So this course does not include any 3D printing. I'm sorry, but I want you to know how to export a part for 3D printing in case you want to do this in another course or for yourself and use, for example, a makerspace or your own 3D printer. So it's actually very, very easy to export a part for 3D printing. So here's the phone stand we made. I have saved it. And to export it to 3D printing, I will click File, Export, and choose CAD format. And the file format used for most 3D printers is what's called STL file. So I will choose that as the file type. And the first time you export the file from your Inventor version, you want to click Options. And then you want to make sure that the settings are correct here. You want your resolution to be high, and you want your units to be millimeters. Those are the two important settings. And then just say OK, and then save your file as STL. What you do after that depends a little bit on your printer, but for me, I use the Ultimaker Cura as my slicer. So this is a bit outside the scope of this course, but I want you to know how to do this in case you want to 3D print something. So I have my slicer. This is what turns my CAD model into G-code for my printer. So I click on Open File, and then I choose my STL file. And you can see it fell in the wrong direction. I want to print it on this back here. So I will just turn it into the correct position there. I've already set all my settings I need. I slice it, and you can see in the layer view how the printer actually is going to print it. And this is the infill pattern I have chosen and all the settings I've chosen. So you can see it's really simple to 3D print from CAD, and I will just save this to the SD card that I use for my printer, put it into the printer, and it will print. A little bit outside the scope of this course, but something that I want you to know how to do. The time-lapse video that's coming just next here in the clip shows how it was printed, and the print time was about 1 hour. So what do you do if you want to edit something in your part? Do you have to recreate your whole model? No, not at all. And this is one of the great things with CAD. You can edit pretty much anything you want. So let's do something simple. Say, I don't like the way these corners are rounded. I want them to be rounded much more. Well, that's super easy. I just go to the model tree, that's the browser here, and I look for where I used the fillet tool. It was apparently the last thing I did. So I just right click on it, and then I select Edit Feature. And now this dialog box comes up that we saw when we made these fillets and the rounds in the very first place. So say I don't want them to be 3 millimeters, I want them to be 5 millimeters. So I just highlight it, change it, and then I click OK. And now my part has rounded corners, bigger rounded corners. And say I don't want these rounded corners at all. I've changed my mind. Well, there are a couple of things I can do. I can just go here and delete it. And now the feature is gone. But and maybe I didn't want to delete it. Oh, I didn't mean to delete that. Then I can click undo. And now it's back again. There's also another cool feature. You will find this maybe useful later on, but I just want to show you that this exists. You can take the end of part and you can pull that up. And now suddenly it disappeared from your model, but it still is down here. So say you want to do something else, and then you want to put the fillets back. Then you can pull your end of part back down again. Again, you may find this more useful later on than right now. But fillets isn't the only thing you can change. You can change every kind of feature. So for example, let's say we want to make this stand wider. So we did it 30 millimeters wide, but I want it to be 50 instead. Well, the extrusion 1, the first extrusion is when we made the width of the stand. So let's right click on extrusion 1, say edit feature, and let's put in a bigger number. So let's add 50 instead of 30 and say OK. And now your stand is much wider. And now you can see, if you remember, when we made this cut for the slot here where the phone goes, we set it to the extent all instead of 30 millimeters. Because if we had said only 30, then this cut wouldn't go all the way through now. But because we said all, it will always go all the way through, no matter how big we make the stand. So now we can see there's another problem. It is that my text is not in the center of the part anymore. So do I have to recreate the text? No, not at all. I can edit that as well. So first I need to find where it is. So if you hover over things in the model tree, you can see them highlight. So I can see the text was made in Extrusion 4. And there's a little chevron here, so I will click on that. And here is the original sketch. And I can change two things here. I can change the feature itself, but there I can just change how big this extrusion is. I can make something really weird like that. Pretty useless, but it looks cool. But I can also change the sketch itself. And to change the sketch, you have to expand this item. So click on the chevron and then right click on the sketch and say edit sketch. And now I can go in and I can move where my sketch is. And I can also change this text. So I can say I really love CAD. Now it ends up on 2 lines. That's all right with me. And I want it just center justified. Here we go. I like that. And then you just say finish sketch and your part updates. So I don't really like this really long text coming out. Instead, I actually want it to be engraved into the part. So I will go back to the model tree again, say edit feature again, and then I'll pull this arrow and all the way into the part. And make sure it's cut. I want it to be about 2 millimeters deep. And then click OK. And now I have engraved text instead of embossed text. So another important thing I also want to show you, and that is if you start a new sketch. Let's start a new sketch on this face. And I want there to be I don't know, little dots sticking out from this face, just for fun. So I make these, and then, oh, I accidentally clicked finish sketch. Oh, but I still want to edit these. They're not fully dimensioned. And what do? Well, don't go and start a new sketch. Because if you now start a new sketch, these circles are not in the sketch where you are working. So if you accidentally exit the sketch, just go to the model tree, right click on the sketch, and edit sketch. And that gets you back to the sketch where you can do dimensions and edit whatever you want to do. But I changed my mind again. I don't want these dots. So I will finish the sketch, and then I will go in here and I will just simply delete it. So try this for yourself. Try all these different extrusions and see what happens when you change them. You can also go in and change its extent. So here we did all, but instead you can change this to a distance. See, this is what would have happened if we had said 30 millimeters for the extent instead of all. So try it for yourself, play around and try different features, different edits, and see what kind of weird looking phone stand you can create. We talked a little bit about line types when we created this phone stand, and if we take a look at our original sketch, the very first sketch we created, we can get that if we go into expanding this item here and then right click on the sketch. We can take a look at the very first sketch we created, and you can see we used normal sketch lines. They started out as green, and then as we constrained them they turned blue. So these are just regular sketch lines, fully constrained because they are blue. But there are also other line types that you should be familiar with. So let's take a look at a different part. So this is a headphone stand that I designed a while ago, but I think it's a little bit bland. I would like some kind of decoration on this back plate here, and I think I would like a row of holes that are on the diagonal. So let's open this part and see if we can make a row of holes. So here's the part itself. So this is the part file, the IPT, and the ones I showed you just before was the assembly file, the .iam. So in order to make this row of holes here on the diagonal, I will start a sketch on this back plane. But it isn't really easy to just eye up exactly where these holes should be. So I like to use something that's called a construction line. So it's a special button up here, this one, and if we hover over it, we can see what construction line geometry is. And that is basically a line that you use as a support or a guide, but it will not extrude if you were to extrude a shape. So we click this button here for construction geometry, and now everything you do, lines, circles, arcs, so on, will be construction geometry until you turn this off again. So let's do a line, and I like to sketch a line from this corner up here down to this corner down here. And then I just escape to get out of the command. So I also automatically get this edge here highlighted. Don't worry about that one right now. So let's focus on this line. So this is a construction line. You can see it's dashed and it's much narrower than a normal sketch line. And it is blue, which means it's this particular line is constrained. But we are missing one dimension, so we can click this the auto dimension button and add that, and then our sketch is fully constrained. So now I want to do a row of holes as my decoration, and the holes will be extruded, so we don't want those to be construction geometry. So let's turn off the construction geometry. So I click the button again, now it's not highlighted, and then I will get the circle tool, and now I can draw my circles here. And maybe I actually want one right in the middle. So let's move these ones a little bit. You can take, if you grab the center of a circle that is not fully constrained, you can push it around and move it where you want it. And I want one of the circles to be right in the middle of this line. And I don't know how long this line is, but I don't really need to know that because the midpoint will automatically highlight. So you aim approximately what you think is the midpoint of the line, and when your marker turns to a green dot, that means that you have hit the midpoint. So if I click here, this particular circle will now be constrained to the midpoint of the line. And then I will go in, I will dimension my circles. I think I want them to be a bit smaller than they are, maybe 10 millimeters each. And while I'm doing this, I will show you another trick. If you want to do these circles all the same diameter, you don't have to type in 10 every time. You can actually click on the previous dimensions, and now this circle will be of the same dimension. And if you notice here, our center circle now turned blue because it's constrained to the center of this line, and it also has a given dimension. So it's that particular circle is now fully constrained. Our other circles are not fully constrained yet. I also want my circles to be evenly spaced, so I will just give it the dimension from this one to this one. I like it to be maybe 22, sounds like a good measurement. And I will do the same from this one to this one. Adding all these dimensions. Sorry, I didn't mean to do that. I want to use that dimension. Okay, there they are, and maybe they're a little bit tighter than I would like them to be. And because all these dimensions now are linked, I can just go in and change this dimension, and all these dimensions change at the same time, and it's quite elegant. So you can see our sketch is fully constrained, and I will extrude these holes. And I like them to go all the way through. And you can see we're still in the sketch environment, but as soon as I click OK and finish this extrusion, it will automatically close and hide this sketch. If we take a look at our original assembly, we can see that a part has updated, and we now have the new headphone stand, or the modified headphone stand with this decorative hole in it. So you can see that when you change a part, it will automatically update in your assembly. In case it wouldn't do this, it happens once in a while, you use the update button up here, and then it will update your assembly file. So there is one more type of line I would like you to know about, and that is a center line. And we will get back to this later, but I will just quickly sketch up or create a keyring that will work well to connect to our phone holder we made earlier. So I'm just going to do a very quick sketch here, maybe make it 3 millimeters in diameter, and we're going to revolve this circle to make a keyring. All the details of this we will come back to later, so don't worry about it. But what I want you to show you is the use of a center line. So a center line has its own button up here as well. And if I click the center line button and then draw a line, I get yet another kind of line. So you can see this is a dash dotted line, and that is a center line, and that's used when we want to revolve something. So I like to revolve this circle and make a keyring. So notice one thing, that my sketch is not fully constrained. My lines are green, and it says that there's 4 dimensions needed, but that doesn't prevent me from actually revolving or extruding this part. So I select revolve, and in this case Inventor has automatically selected my cross section because it's a simple sketch, and it has also automatically selected the center line as the axis of revolution. This often works, but not always. If it doesn't automatically select it, you just click on it to set the axis of revolution. So one thing you may notice is that this sketch actually revolved despite the sketch is not fully constrained. And that is not really good. It's a better habit to make sure your sketch is always constrained before you revolve or extrude, because that makes your design more robust. So here is the keyring that we could now use to make an assembly with our phone holder. And I am just going to change, make it out of stainless steel so it looks a bit nicer. And if we open this sketch again, I just want to show you one last thing. And that is the center line now is green because it is not fully constrained. But if I were to use the automatic constraints, and I apply all the constraints, and now my center line turned blue, just like most constrained lines do. They turn blue. All the line types we have covered so far turns blue when they're fully constrained. So there you go. There are a few line types that you should be familiar with when you work in Inventor. You did several extrusions when you created the phone stand, and that seemed to be very straightforward. Everything worked great. So I have made a sketch here. It looks great. All my lines are blue. It's fully constrained, and I want to extrude this shape. So I go to 3D model, I click extrude, and then it automatically selects this profile. But there is a problem here. So I tried to pick a solid as my output, and it doesn't work. And I get this error message, and I'm just going to ignore that for now, and I choose surface instead, and that seems to work great. But I don't want the surface, I want a solid model. So let me click on solid again, let me click on my profile, and then let's take a look at what this error message actually says. So we get an error message saying that no valid closed regions could be generated for the profile selected. Try selecting a different profile. Well, I don't have a different profile, but clearly there's something going on with my profile. So when you try to extrude something or revolve something, and the resulting body you get is actually not solid, but only a surface like this in kind of orangish red color, you have a problem with this profile. So let's cancel out of the extrude command and see what is going on. So this looks like a pretty good profile to me, it has all the dimensions, but there's clearly something wrong. Somewhere there's a tiny little gap in between my lines. And there is a way of fixing this. And it's quite hidden and quite obscure, but a very good thing to know. So if you right click on any of these lines and then you choose in this menu close loop, we click on that and we get this message. It says select the curve that is connected to the start end of the open loop. Continue selecting curves until the loop is closed. Okay, so let's do that. So we selected this one, and then clearly all these other lines are connected to this first line. And then we get a message saying there's a gap between the endpoints for the highlighted sketch curves. Would you like to close this gap? So clearly Inventor has identified that between this line and that line there is a gap, and that's why we couldn't extrude this shape. And I say yes. Well, didn't really work. We get another error message. It said you can't do this. And okay, let's cancel that and take a look why we can't do this. So let's cancel, and then first let's zoom in and take a look, and what do you know? In here there's actually a gap. And that's why this thing cannot be extruded to a solid body. But to fix this gap, I need to remove a few dimensions because this is fully constrained and therefore this profile can't be repaired. So let me delete that dimension and that dimension, and then let's do close loop again. So right click on any line, select close loop. We always get this message. Click on this and let's see if it works this time. There we go. So now Inventor automatically repaired our profile. It assumed that we wanted a closed profile because we asked for a closed loop, and now we get a message the loop has been successfully closed. So I still actually no. By doing so, my sketch also became fully constrained. So we're all set there. So let's see if we can extrude this again. So now when I extrude it, my output becomes a solid. So if you try to extrude something and it doesn't work, take a look and make sure there aren't any gaps. Use the closed loop command. If that doesn't work, you may have to remove some dimensions or manually repair your loop so it's a continuous profile. There we go. Here's my little house-like design. So the revolve command has the same requirement as the extrude. If you try to revolve a profile that isn't closed, you will get the same problem that your output will not be a solid body, and you will fix it in the same way. You used a few different constraints when you made the phone stand, and just let's take a look at the remaining constraints and how we use those in sketches. So let's start a 2D sketch, and let's pick the XY plane. It's my favorite plane. And take a look at the constraints that we find here on the screen. So let's start by drawing a couple of lines. So I'm just drawing a line here and another line there. So I told you that it's always a good idea to start your sketch at the origin, to anchor it to the origin. But if you forget to do that, you don't have to redraw your sketch. What you can just do is to use the first one of the constraints, which is the coincident constraint. And then that one constrains 2 points in a 2D sketch. So let's say we want this line to be connected to the origin. Let's just click on the constraint button. Click on the end of this line and then click on the origin. And now this line, I pressed escape to get out of the constraint. You can see that this line is now anchored to the origin. We haven't decided its exact length, angle or anything else, but that point is now connected to the origin and it won't move. So that's how the constraint button works. And you can use that for a whole sketch, not just a line. Let's say you have a sketch like this, and let's delete this line to get it out of the way, and I want to connect this corner here to the origin. You can just do it the same way. So we'll just move the whole sketch, provided that it isn't connected to something else, and connect it and anchor it to the origin. So that's the first one. So let's delete this one for now. So the next one is collinear constraint. It makes 2 lines in line with each other. So let's draw another line over here. And if we want these 2 lines to be in line with each other, we click on one and click on the other. And now the 2 lines are in line, which is very handy. But they're still not connected to each other. So you can see we can move them. We can make it longer and shorter. But they will always be in line no matter what we do. And if you want to know what kind of constraints you've added, you can use the button down here in the bottom of the window, which is called Show All Constraints. So the constraints are hidden in the normal sketch mode just to make it less cluttered. But if you want to see what you have, you can click this button and they will be visible. You can delete this constraint. Sometimes it's a little bit tricky to get hold of them, but if you do, you can right click on it and delete. And now these 2 lines are not constrained anymore. So if we just continue on looking at the third button here is the concentric constraint. What it will do, it works on circles. So let's say we have 2 circles. Let's draw a small circle and a big circle, and I want these 2 to be concentric, so I want them to be inside each other. And then I can use this constraint, and now they are 2, they share a center point. So if I try to move them, I will move both circles. You can get the same results with a coincident constraint, and that way connect the circles. The fourth one here, fix. That one will basically lock down your sketch element to the exact location on the sketch where it is. So it's now pretty much just frozen in space. That is sometimes useful and sometimes not as useful because you can't really do anything with this sketch now. Or this particular sketch element. These other ones are still free to move. So I suggest that you pause the video and then you just try to play with these 4 constraints, and then we will cover the rest here in a moment. So just take a break or pause the video and try for yourself how you can use these constraints to connect lines, line up lines, and make circles concentric. Alright, I assume you did that and you tried these different constraints so you understand how they work. Let's continue to the second row of constraints. So our first one is parallel constraint. So it indicates that this is a constraint you would use with lines. So let's draw 2 lines like this. Make this one a bit shorter. There we go. And if I want these 2 lines to be parallel, I use the parallel constraint. And as always, if you hover over the button, you will get an explanation telling you what this feature does. So click on one, click on the other, and now the 2 are parallel. Still not constrained in any other way, so we can move them around, but they will always be parallel. Even if I move the angle, change the angle, the other one will change with it. So I'm just going to undo to get out of all the constraints. The second one is somewhat similar, the perpendicular constraint, but in this case instead, it will constrain it in 90 degrees to each other. There we go. And to get out of a constraint, you do as you always do. To stop a command, you press escape on your keyboard. So let's delete those. Next one is a horizontal constraint, and it pretty much explains what it is in the name. So if I have a line like this and I want it to be horizontal, I use this constraint and that will make the line horizontal. Just undo that. And then the second one is a very similar, but instead it is vertical. You will notice if you have added one constraint, like now we have added the vertical constraint, if you try to add a horizontal constraint to the same line, we will get this warning saying that you can't do this because it would over constrain the sketch. And it makes sense. If you have constrained it to be vertical, you can't also constrain it to be horizontal. That would simply not work. Alright, so do the same thing again, pause the video and try out these commands for yourself and see how they work. Okay, so let's do, before we get to the last row, let's try to use a couple of different commands on the same line. So this line is now constrained vertically, and I also want to constrain it to the origin. For some reason my origin is not visible. So my origin disappeared when I deleted all my lines here. And if this happens to you, it's an easy way to get it back. So we will use a command we haven't really used yet, but we will get back to it later. But project geometry. So use project geometry and then click on the center point here in the model tree. You may have to expand this origin folder. Click on the center point and that gets our origin point back. So as always, press escape on your keyboard to get out of the command. And now we can use the coincident constraint and we can constrain our line to the origin. And you can see now there's down in the corner says that one dimension needed to fully define the sketch. And what is missing is that we haven't defined the length of this line, but we won't worry about that right now. So let's draw another line, and I'm going to do it at this angle. And now if we wanted to make these two lines parallel, I can use the parallel command. So now I just want you to think for a moment. What happens if I click on this one and this one using the parallel constraint? Which line will move? All right, you've been thinking about it. So let's try it. There we go. So this one line will move because this line is already constrained and cannot be made parallel to the other line. So sometimes things may not move exactly in the way or constrain exactly in the way you want, and then you have to think about what have you done and what constraint may there be already that interfering with what you're trying to do. So try this a bit on your own, and you get a feel for how things work. So let's go to the last row. We have a tangent constraint, and if you think back to geometry, you remember what tangent means. So a tangent, in this case, we will need a circle, and then we will need a line. So the tangent will make our circle, tangent constraint will make our circle tangent to our line. It's pretty easy. But we can still move the circle, we can still make it smaller and bigger, but it will always be constrained and be tangent to this line. The other two here in the middle, we will skip those for now. We won't really need them quite yet. So you can explore them on your own if you like, just read up and see what they do, but we won't cover them right now. And so let's go to the very last one, equal. Again, the name really says what this one does. It makes two lines of different length, the same length. There we go. So these are now the same length, but they're not at the same angle, and they're not parallel to each other, and they're not constrained in any other way than they are the same. They are of the same length. So let me undo that, and then let me add a dimension to this longer one. I want this, so if you notice one thing here, when I add the dimension, this is actually horizontal dimension, but this means my line is not exactly 70 millimeters long. It's actually a little bit longer because it's on an angle. And if I want my dimension to be aligned with the line, then I would right click and pick aligned dimension instead of the horizontal one. So aligned. And I'm just going to accept that value. Now if I use the equal command and I click on this one and this one, now the shorter one becomes longer because we have constrained the length of this line. If we just do one more thing, let's also give the little one, the shorter one, a length. And if we try to use the equal command, we will get an error message saying we can't make these equal because they both already have a set length. So there we go. You have covered the most common constraints. So again, go ahead, try to sketch something, try the different constraints, try the other commands we have learned, like extrude, revolve. We haven't really covered revolve, but extrude, and just explore features on your own, because that is how you learn CAD. If you accidentally close the model tree, so it disappears like this, and you panic because you can't find it, you can't work on your part, and you restart Inventor, and you will notice that the model tree is still gone because it remembers your settings. So the way to find your model tree again is to go to the View tab, to User Interface, and click the little box that says Model, and it comes back. Even more scary is if you accidentally remove the ribbon. So it suddenly looks like this, because now it's almost impossible, or at least in my opinion, to find any of the commands. And again, if you restart Inventor, it will remember your settings, so the ribbon will still be gone. First time this happened to me, took me almost a full day to figure out what had happened. And the key to get it back is this little button up here. And just click on it, and it will cycle through different ways that you can display the ribbon. So you can find your favorite version. I like this best with the big symbols, but it's all up to you. So the big chevron button here, not the little one, but the big one here. Just click on it, cycle it through, and you will find the user interface again. We have come to the end of this introductory video to Autodesk Inventor, and I hope you enjoyed it and hope to see you again in the next video. Until then, happy CADing!